All right, the second half of Chapter 8, Section 5 is about the law of cosines. So that's what you should be able to do at the end of this lesson, is to be able to solve parts of a triangle using that law. And like we learned today, the law of sines can't be used to solve every triangle. Remember we said that we can use the law of sines if we have an angle, and then a side, or if we have a side, and then an angle. But if we know two side lengths in the included angle, like side angle side, or if we know all three side lengths, we can't use law of sines. Instead, we have to use law of cosines. So this here is law of sines, and these here is the law of cosines. So this is what the law of cosines look like. And I know it's very confusing, but we still have the triangle ABC. Angles are across from sides. And there's a pattern here to notice. So if I have the side A squared, I'm going to end up somewhere in this taking the cosine of the angle across from it. And if you notice, that works for all of these variations that we have here. So your side that you're looking for equals the cosine of that angle along with some other stuff. The other pattern to notice is that these other two side lengths here appear next to the cosine. They get multiplied by the cosine that you have. And then you always subtract 2 times all of this stuff. So we'll prove this in class so you know the why behind it, but right now we're just going to use these. So find this measure, xz. We're going to round lengths to the nearest tenth. So xz is this side right here. And if you look, they give us the angle that's across from this. So that helps us with whatever variation of this you decide to use. So let's call that angle A, or side A here. That's what we don't know. So let's rename this angle A up here. And then it doesn't really matter which one you label B and C. And you don't really have to rename these, but when we're plugging them in the formula, it kind of helps. So the thing to keep in mind is that you need this angle, and we have to find this side. So I know that that side squared has to equal my other two sides squared and added together. Kind of looks like the Pythagorean theorem. And then I'm going to subtract 2 times those side lengths, so that should be BC, and then times them by the cosine of the angle across from the side that I want. So then you just plug stuff in. A squared is what we don't know. We said B was 35. We called C 30, minus 2 times those side lengths multiplied together, times the cosine of the angle we know, 110 degrees. And then this just turns into a huge calculator problem. 35 squared is 1225. 30 squared is 900. If I do 2 times 35 times 30, I end up with 210, or sorry, 2,100 times the cosine of 110. And now I'm just going to type all of that into my calculator at once. So 225 plus 900 minus 2 times that 2,100 times the cosine of 110. And I end up with a squared equals 3,561.48. And then leaving that in my calculator, I'm just going to take the square root. So A equals about 59.678. But they told us to round to the nearest tenth, so that's only one number after the decimal point. So we'll call this about 59.7. And that's that side length over there. So let's try another one. If you looked here, we were given a side, an angle, and a side. That was one of the ways that we said we can use the law of cosines. This one over here, we're given all 3 sides. So that means they're going to ask us to find a measure of an angle, and we want this angle right here, angle T. So when you're doing the law of cosines, we are going to need to take the inverse cosine eventually to find one of these angle measures. And again, it doesn't matter which one you use. So I'm going to write the first version of the formula. So we have it to reference. Remember, these two appear here, and then it's times the cosine of the angle across from that one. So to make it work with our sides, or with our letters, instead of A, I want T here. And instead of BC, it's my other two sides. It's this side here, which is side S, and this side here, which is side R. So that means S squared plus R squared. And that's going to equal this side over here, which is a little t. And then all we got to do is plug stuff in. So 7 squared equals 13 squared plus 11 squared minus 2 times 13 times 11 times the cosine of angle t. And again, you're throwing it in your calculator. And then you do 2 times 13 times 11 gives you 286. So I'm going to simplify this. 169 plus 121 gives you 290. And remember, I want to get as much done before I have to type anything into my calculator with the cosine button. So I'm going to subtract this 290 from both sides. So when you do that, you end up with negative 241 equals negative 286 times the cosine of angle t. And because these are multiplying, we can undo them with division. So divide that, you get 286. You get 0.8427 equals cosine of angle t. Now I'm going to leave that in my calculator so that I don't have to round. But remember, the opposite of cosine is the inverse cosine. So that's what I'm going to take the inverse cosine of. And I end up with 32.6 degrees. But it said to round to the nearest degree, so we'll round up to 33 degrees is how big this guy is. So we'll do more practice with this in class, but that's it. You should be able to use the law of cosines to solve for some triangles. Write down any questions you have, and we can talk about them in class. Have a good night.